Good evening, everybody. So today is September 7th, 2021. So let us start our lecture. So according to our schedule, so this week we will be discussing linear time sorting algorithms. Okay, so according to our schedule, so this week we will be discussing linear time sorting algorithm, chapter 8 in the book. So chapter 8 is sorting in linear times. That is something that linear time sorting algorithms we will discuss with you. Okay, so far we discussed some sorting algorithms, right? In terms of the complexity, when we found that the merge sort algorithm is so far the best sorting algorithm. In terms of any input size n, its complexity is, in the worst case, its time complexity is big O n log n. Okay, and we discussed in our last lecture the heap sort algorithm that takes also n log n time. Okay, and the quick sort algorithm in best cases it takes also n log n algorithm. But among the algorithms that we discussed, this is a quiz question, is the quick sort algorithm is the quickest running time algorithm? Is the quick sort algorithm the shortest running time algorithm? No, its name is quick sort, but it cannot sort quickly as other algorithms can do. Like the merge sort algorithm, it has guaranteed time. It has guaranteed time complexity that in the maximum case it will take big O n log n. But then you see that in the quick sort algorithm that does not take always. Okay, sorry, some of you the last lecture videos was not recorded. The sound was not recorded. I will record that sometime next week. Okay, and I will upload this. So so for the algorithms we discussed, so the merge sort algorithm is one of the best algorithms so far that has big O n log n. Okay, time complexity. So it is kind of linear sorting algorithm. Linear means complete linear means as your input size grows, your time, it will take more time equivalently. But for not always that this merge sort algorithm like that this algorithm it takes linear time because it has another constant log n. There is another constant value. For instance, if I have 1000 log value, n value is 1000. For instance, if n equal to 1000, for instance, and then big O n log n will be 1000 times log 1000 of 1000, right? This is 1000 times, we know the log of 1000 with base 2 equal to approximately 10, right? Because log 1000 we are considering base 2 is equivalent to log 2 to the power 10. Actually 2 to the power 10 equal to 1024, right? So then it's approximately 10. So that means its base value is times 10, that means 10,000 millisecond or microsecond, whatever our input timing unit is, it will take that much time. So it is not actually linear. This algorithm that takes big O n that is not actually linear. It's pretty linear. So a lot of research are going on, research work are going on to develop new algorithms or better algorithms that takes less time. Okay, so the people, computer scientists, they have goal to develop an algorithm that takes, in the worst case, log z n times Okay, if it is not possible, then big O n. Okay, and if it is not possible, so far we got big O of n log n. So that is guaranteed. We got it right for Marshall algorithm. Okay, and it is acid partially. For some algorithms, it is true. For some data, okay, for some specific kind of data, it is possible to develop an algorithm, but yet it is not possible. It has not been developed yet. To develop an algorithm that takes log n time. Okay, so still a lot of research are going on. So now tonight we will see that is there any algorithm, sorting algorithm, that really takes this linear, this big O n running time, or if it does not exist, is there any clause related to this, pretty close to this? Yes, there are some algorithms that are that have running time pretty linear, not exactly linear. Okay, so we will discuss this. One of this is called, the popular algorithm is counting sort algorithm, and then we have radix sort algorithm, another one, and this the third one is bucket sort algorithms. These three algorithms are pretty linear time algorithms. Okay.
What was the second one? I didn't hear it.
Radix sort algorithm. I will go one by one. In case I cannot go all of these three, at least I will go two. Okay. And then I have one more lecture this week. We will discuss this. Okay. The discussion, preliminary discussion, is that we know the why so far the efficient algorithms have n log n in the worst case. Is guaranteed, right? So because we know that the Marsh sort algorithm, okay, it uses divide and conquer method, and it splits the data size into two halves. So then for two halves, it takes, in a previous lecture it discussed, so making half, every time it will make half, so it will take log n time to split. Okay, and then n time is that number of comparison number of comparison it will take. Okay, so and merging, and then so this discussion is about why the discussion detailed with an example why the so far the algorithms we discussed takes n log n time, not smaller than this. Okay, but we will discuss tonight with counting sort algorithms. So maybe it is a new kind of algorithm. You may not have used it, but you may be familiar to it if you in your data structure course. Is anyone knows about this in your data structure course? Do you know? Okay, so counting sort algorithms. So the name infers that we will be counting, right? Counting means we'll be counting how many numbers are there. Yes, we'll be counting, but with a technique. With some technique, we will be counting. Okay, so we will know about that. So this is a given data size, an array. A is given input array, and the output array is this one, is our expected output array. Okay, in order to get the output array, this is sorted, right? For is very small data size, like is this small data size, it is intuitive that it is easy to say that this is sorted. But the underlying process is not the big algorithm. You see there are a few lines, 10 to 12 lines, but there is some complexity because especially the first few lines last few lines. This second half is complex. Okay, so first of all, then like many students, I try to understand this. Then it's difficult to understand. So if you read the book, apparently you will read this discussion first, and you will be trying to understand this, but it is difficult. I like to give you as a homework to study. If you can understand, that's good. But if I have some time, then I will help you, give you some clue with this. One problem is that we know that in our program, I will also give you an actual program to you to play with. Okay, don't worry about. Just give attention, please. Okay, everybody, please give attention. Do not open any more device. Okay. Okay, and then you see that one problem is that in this book, it is written in old-fashioned pseudocode format. So the index start with 1, right? In array, that is kind of difficulty for me. So we are familiar with index 0 in programming. That is one problem over here. And see that A array is given with index 1, and then B array it is also given with index 1.
Yeah.
Okay, but we need to adjust it. We need to adjust our mind, or you can write in our, using a pencil, you can rewrite the indices from 0 to, this will be 0 to 7, this will be 0 to 7. And if you write 0 to 7, then you need to adjust this course a little bit.
Yeah.
This code. Okay, now let us go through this algorithm first, instead of going example. Okay, so the algorithm is counting sort algorithm. It says it will count. We'll see soon what we do. What do we count? Okay, it takes an array A, input array, and B is the output array. We will get it. This algorithm will return B. Okay, and K is a number. Okay, then let us keep our mind what is K. Okay, then we need to take another array, C array. Okay, that size will be 0 to K. Okay, and for I equal to 0 to K, so we need to initialize this count array with 0. This is straightforward. This is very straightforward. So let us go with example. Let me see this example I can give you. So this is A array. Okay, so here is B array. Initially let us think that B array is empty, or we will declare it. So A array has given some values, right? 2, 5, 3, 0, 2, 3, 0, 3. These are our raw values. But in the final we need to get 0, 0, 2, 2, 2, 3, 3, 3, 5 sorted. Okay, so then what is K value over here? K is the range. Okay, the range, that means what is the minimum value and what is the maximum value. These are called key values, or given values. What is the minimum value over here? 0, right? What is the maximum value over here? 5. Okay, K is the max value over here, 5. So range is 0 to 5. One thing is that this sort algorithms, counting sort algorithm, works only for positive numbers and integer numbers. It does not work for negative numbers. It does not work for decimal number, floating point numbers. Okay, floating number or decimal type. Okay, these are two limitations. Okay, we assume that we have our data like this, whole numbers and whole positive numbers. So we can get the K value quickly, right? How can I get the K value? By finding the maximum element using n time, right? For running a loop n times, we can get the max value. Okay, so now we will declare an array C, okay, with, okay, so 0 to K size. So here we see that with K size K. So here, what is K value over here? Let us see that. What is K value over here? What did you find K value? here k equal to 5, right? 5, right? The max value is 5, so k equal to 5. So then we will declare an array. This C array will have 5 elements, size 5. Initially, let us assume that this C, initially C will index 0, 1, 2, 3, 4, and 5. Okay, so 0 to k. Okay, that means C has size 1 more than the highest value. So 0 to k, what is the size of this one? Size of, that means I can say k c dot length. C is our this array is C. Okay, c dot length equal to k plus 1, right? It has length 6, right? 0 to 5 equal to 6. Okay, so initially we put this statement here. It says this says for I equal to 0 to k, put ci equal to 0. So this is straightforward, right? In one loop we can find, right? For the first one, how can I get c? Like if we run an algorithm, we run a loop for I equal to 0 to I less than n, right? N means a dot size, a dot length I plus plus. So we can say int max equal to ei, or then you can say it can start from 1. If e of I greater than max, then we can say max equal to ei, and by this way we can find the max element, right? Max element, then max element will get 5. So then k will be the max element, right? K will be max element 5, and the length, c of length will be k plus 1, max element plus 1. Okay, so that is linear, or you have only one loop. Okay, now how can this one, right? So we need to put all, you can run another for loop, I equal to 0 to k, ci equal to 0, that all ci, this one will be 0. Okay, so up to this is straightforward, right? Is there any question? No, I think it's straightforward. Now let us see that what does these two lines, line number 4 and 5, do. Okay. Let me draw C over here. Okay, I do have C over here. Let me get another color. Okay, so now these lines 5, 4 and 5. Okay, this is another for loop for I equal to 1 to n. So in the book, so they started with index 1, so they put 1 to length, a dot length. Okay, if I use my our program code, then what I will do for I equal to, or they put j, anything, I or j, whatever you put, that's not an issue. J equal to 0 to j less than, okay, they put 2 means equal, put a dot length length, okay, j plus plus. I will put c of aj equal to, what is c of aj? What is aj? So our a, do I need to rewrite it? Okay. I'm sorry. A equal to this indexes. They put a of j. So a of j. Let me erase this one. I don't need this one. So you understand this one. We need a. Okay, please give attention about it. It is little bit critical over here. So what we are doing, c of aj. Let us first find aj. What is aj? J equal to 0, right? What is aj? A0. Okay, sorry. So a0, let us put this is from 0. I understand from 1 to, so this is 8, this will be 7, right? Okay, I'm rewriting the index so that it coincides with my code. Okay, so a0 equal to what? 2, right? Okay, that means a0, that means you will get c of 2 equal to c of same thing, it will increase by 1, c of a j plus 1. So what is c of aj? C of 2 plus 1. That means we are updating c of 2 equal to c of 2. Originally it was c of 2, originally it was 0, right? C with index 2. What is that? C at index 2, 0, right? So then we are upgrading is 0 plus 1 equal to 1. So this 0 will be replaced by 1. That means you can say that in the given array, so far there is 1, 2. 2 exists one time. 2 exists one time. So we have gone so far only one element. We have not gone through all of this. Okay. So similarly, if we go to the next index, okay, we increase j, we will go this one 5. Okay. So then c of 5, we will see the c of 5. What is c of 5 over here? C of 5 is originally 0. C of 5 is originally 0, and we got 5 over here, c of 5. So then we will increase this by 1. We will increase this by 1. That means in this array so far we got 5 one times. We have 2 one time, we have 5 one time. So we got 2, and then c of a of 2. For the next a will 2. So then we will see c of a of 2 will be, this is our 2. Okay, I'm not using this index, so is 3. So then we are coming to this count array, and we are updating the position, the value at index 3. So at index 3 it was 0, so then it will get 1. Then again it is coming at 4, index this on 3, this index 3, and then it got 0. Okay, and then at index 0, okay, and it is updating by 1, so this one will be 1. Okay, and at this will be next index, so then it got 2, then it will come to index 2, c of index 2. Okay, it is originally 1. previous step 1, right? And then it will increase by 1, so this one will be 2. Okay. So and the next one, it will go to by this way, so it will go all the way end, and then it will find this C. It will get updated C array. Okay, so what this array will tell us that in this array, do you see that in this array? So what did I find? So let me rewrite this. What did I find? C equal to at index 0 equal to 2, at index 1 equal to 0, at index 2 equal to 2, at index 3 equal to 3, at index 4 equal to 0, at index 5 equal to 1. So this algorithm could be finished at this point. Major part is done over here. Okay, so what does this array tell us? It tells us in the original given array there are 0 2 times. There are 2 zeros. Let us see, are there 2 zeros? 1 0, another 0, 2 zeros, right? And there is no 1. 0 1. Okay, 0 is 1 time. Sorry, 1 is 0 time. There is no 1. It does not have any 1. And it says there are 2 times 2. 2 exists 2 times. So you see that 2 exists, 1 and 2 again. Okay, and it says that 3 exists 3 times. You see that 1 here, another 1 here, another 1 here. 3 exists 3 times. Okay, and there is no 4, and 5 exists only 1 time. So you see that within the here 5 exists only 1 time. Now if I could write another easy algorithm, that we know that, oh, we have 0 1 times, so then if I could write an algorithm, something, okay, that not this way, that then if we can try ourselves, okay, to work together. Then if we can write an algorithm or quickly in linear time, that will say, oh, we know that it has 0 1 time, so we need 1 0. Oh, sorry, 0 2 times. It says it's confusing to me sometimes also. So 0 2 times, so then with 2 zeros. Okay, and then there is no 1, and there is 2 2 times, so 2 2, and there is 3 3 times, 3 3 3, and there is no 4, and there is 5 1 time. Okay, if I could write this easily, we can write this easily, then it is done, right? So this is the output. This is the output array. Right, this one 0 0 2 2 3 3 3 5 0 0 2 2 3 3, right? This, where can I get this? This count array tells us, right, there is there are 2 zeros, no 1, 2 2s, 3 3s, no 4, and 1 5. That means we can easily get rid of the 0 values. Then you can say 2 zeros, 2 2s, 3 3s, and 1 5. But that part is difficult. Okay, there are two reasons. There are some reasons that why this part is difficult. So for implementing this, ultimate goal is to find this, right? That will be sorted, but in order to implement this is not that much easy yet. Okay, two things. The reason is that one purpose is that this, in order to use this count sort algorithm in other algorithms like radix sort algorithm, we will see soon, it needs to be in place algorithm. In place, that means it will, this, for instance, there are two, like two, how many times? 2 times, right? There are 3 times 3 times 3. Okay, if these are only numeric value, then fine, right? But if these values mean something else, okay, for instance, this 2 is the GPA of one student and this 2 is GPA of another student. Okay, this 3 is the rank of one student, this 3 is the rank of another student, this 3 is the rank of another student. In that case, we should, if and we need to maintain the status who comes first, right? If you want to give priority, first come first service, right? So in that case, even those 3 students have same value, rank 3, but based on their arrival time, right, this one should get priority first, right? And this person will get another priority and this person will get least priority. So if we need to ensure that, then that part is difficult, that part is not that much easy. We cannot easily write algorithm quickly, so then we need to do something else. Okay, I will go through the next part, but so far, does anyone has any question? This part is straightforward, right? That in this array we are counting how many zeros, how many ones, how many twos, how many threes, how many four, how many fives. So why we are stopping at 5? Because we know that 5 is the highest index, right? Yeah. In order to start this k value, so we declare this array with k plus 1. So this, you see that this book, this mixed up. For this C array, they started with index 0. For A array, they started with index 1. So if you read this without reading the algorithm, if you read this first, you'll be confusing. You'll be confused. You may be, as I did. Okay. So this is why I like you to go to with an example code. Okay. So now the next part. In order to make it in place algorithm, okay, what do I need to do? First of all, we need to replace this, update this count array as a cumulative array. Cumulative array, that means we need to count C equal to, we need to make C equal to 0, 1, 2, 3, 4, right? So this is index 0, 1, 2, 3, 4, 5. Okay, we need to count, what is this one, say for k equal to I to 1 to, they put 1 to k. So but for our algorithm, if we write in program, we will put 0 to k minus 1. Okay, whatever we say, that 0 to k minus 1. Okay. Then what do we say, that Ci equal to Ci plus Ci minus 1. That is, we are doing cumulative. I think we need to start it from 1 to k. I think for here 1 to k is fine. Okay, 1 to k is fine, not from 0 to k minus 1. 1 to k is fine. What we are doing, we are making cumulative sum. So this one, the first value will be as is 2. The second value will be 2 plus 0 equal to 2. Okay, and the third value will be equal to 2 plus this 2 equal to 4, and then next value will be 4 plus 3, 7, and the next value will be 7 plus 0 equal to 7, and the next value will be 7 plus 1 equal to 8. This now the C is updated as cumulative with cumulative value. The first one is get as is, first value as is. The second value will be this value plus previous value, Ci plus Ci minus 1. So this is getting this plus this, 0 plus 2, it will be 2, and the third one will be this 2 plus this 2, 4, and the next one will be 4 plus 3, 7, and the next one will be 7 plus 0, and then next one will be 7 plus 1 until was that way. So it is not difficult, it is all straightforward, right? Okay, now we are updating this C. So C no longer contains this value, right? The array C contains the different values. Remember that? Now we will use these values to find our output algorithm, output array, like this. So here is a tricky part. Okay, let me try if I can help you to understand. So in order to do that, I should redraw this input array. So this is our B, this is our expected, and A is our given array. Just let me redraw it. 2530 2530 2303, right? 2303. So this is our given index, given array. Okay, index 0 1 2 3 4 5 6 7, index 0 1 2 3 4 5 6 0. I'm sorry, 6 7. Okay, don't, I will rewrite it here. Okay, I will rewrite it here. So the program code, or if you want to go through with this exact code, then you need to put index 1, index 1, and B for index 1. Okay, because I'm going to the program, so the program has an index 0. So this is why. Okay. Now let us see what does this line do. Okay. Let me erase this. Okay, everyone understand this, right?
Yes.
So we don't need this one. Yeah, everybody please give attention. Do not open your device. If you understand this part, then you are done for tonight. You will have something to take home, okay?
Yes, sir.
Okay, so for here we will start, this is our input array. We will start from the end, from the tail. Okay, I will tell you soon why we are going to start from the end, not from the beginning. Okay, how can I get the last index? This one. This is my array length minus 1, right? Okay, for I, so int I equal to e dot length minus 1, right? So we are starting from the last index, then we will be going this way. So then, so we will be I minus minus, right? We are starting from a largest index, and we will be starting from right, and we will be coming towards beginning. So this is why I minus minus. Okay, so now looping here. So what we will get, we will get a of last this value. How can I get this value? we can get a, okay, this value 3, okay. So then you can get, let me write it down, equal to, we can put a of I. So what is ai over here? 3, right? I equal to length minus 1, that is equal to 3, right? Okay, so now what we will do, we will go to the index at 3 index in C, this updated C. What is the 3 index in updated C? Here, right? Index 3 is here, right? You understand the index 0, 1, 2, 3. So this is 3 index, right? And then we will get the content 7. What is the content of index 3? At index 3 in 7, in C is 7, right? So we say a I, okay, okay, ai will be 3, right? And then we will go to C to get value at ai, that means C of ai, we are getting C of ai. If we give C of ai, okay, we are getting C of ai. C of ai will be 7, right? C of ai will be 7, but actually we will not be putting this at 7. What will be, we will be reduce this index by 1. So then what is I'm getting over here? 6. 7 will be replaced by 6, and then whatever that value at B of that C position, B of B at 6. So at B, so 6, we will put what that value, ai equal to 3, A7, right? A7. That means A7 equal to, what is this A7 equal to? 3. So that means these 3 will go to my output array with index 6. This is index 6. Tricky part over here. The reason that why I need to subtract 1, why I'm not able to put exact position over here, why I cannot put. The reason is that you see that at some point we will get the value 8. You see that at some point we'll get 8. So if we want to get the value of that we want to get the index 8 position at B in the B array is maximum 7, right? We cannot get 8 position 8 with index, right? So it will make out of index error, right? So this is why we need to subtract 1. So we'll be going almost always one position back. Okay, so then we got 3 over here. Okay, so we got 3 over here. So let us go to the next one. So for the next one, I will be increased to -1, right? So initially I was length was 7, okay, length was 8, right? 8 minus 1, 7. Now this will be 6, right? This will be the initially, what was this one? This one was length minus 1 equal to 7, right? So this was 7 minus 1, then we got 6. Then in the second iteration, so this is okay, then there is one more, there is one more value over here. So then what, after we do that, we need to decrease this value by 1, so 6. So this is that line. Okay, C of Aij, we need to decrease it. This value will be decreased by 1. 7 will be 1. Okay, in the second iteration, let me rewrite this. In the second, if you understand this one, maybe you will be understand, you will be clear, or 1 or 2. So second one will go, we need to go I minus 1, right? I is decreasing by 1. So what was I value over here previously? 7. Now this time I value will be here A6, right? What is our A6? A6 is 3. Did I do mistake any? 7. Oh, sorry, you need to come here. This error, I'm looking for this error. So I at A6. Okay. So what is A6 value? 0. A with index 6, value at index 6, 0, right? So we will get 0. And where this value will be put? So this value will go A6, C of A6, that means 0, then C of 0. What is C of 0 value? 2, right? We got 2. Then minus 1. And this one will go for B. At B of, that means this will be B of C0 equal to 2, right? 2 minus 1 equal to, that means we will go at B1 will be value will take 0. So B1 it is taking value this 0, this one, so 0. Okay, and then what is doing, that the last line will be doing, it is decreasing by 1. So 2 will be 1. Now in the third iteration, okay, we don't need this, so we will go here, right? In the third iteration, what we will do, in the third time, let me explain it here. We will go these of A, we will go with at A this value 5. First we started 7, then 6, then it's 5, right? At A, what is the value of A5? 3, right? Then we will go to the C at the index 3. We got 6, right? And then we decrease 6 by 1. We will take 6 by, we will decrease by 6 by 1. Then we will go B5 at B5. So this is our B5. This is our B5. Okay, and we will put this value at B5. So this 5, this 3 will go at B5. This 3 will go at, what is not writing? This 3 will go at B5. Again, give attention please. What we will go? We will go at 5 in the given index A, the given array A. Okay, in the right side, we will take this value, this 3, A of 5, okay, at A5. This is the middle one, the very internal one, A5. We got this value, 3. Then we will go to C and look at what is the value at C3. This is 6. And we will go at B5, 6 minus 1. Okay, this is B5. This is B5 position, right? So B5 position. Do not confuse that this was empty. So when you declare B, this was empty. Okay. So this 5, B5 at this position, what value we will be putting? this same value be 6 a5 3 will go over here. Now if you understand that other parts will be same. Now we will come here, we will go at index 4 value a with index 4 2, then we will go to C array with index 2, value is 4, then we will go to B array with index 4 minus 1 equal to 3, so this is 3. At this 3 position we will put this value, these 2 will go, so this 2 will come, this is not directly going here, it is going to link over here. 4, it's not exactly going to 4, it is going one step down, okay, and then 4 it is coming over here 4, so this 2 will come at 3, okay, this one. Then we are going to the next position 3, okay, coming here, so then what is the value? 0, right? Then we will go to C at index 0. What is our value? 1, not 2, because we already have 1, so we already used it 1. So now 1, this 1, and every time after use this we will decrease 1, we will decrease this by 1. So this does last statement, it does, okay. Then we got value 1, and then we will go B at B 1 minus 1 at B 0, right? So at B 0 we will put this value 0. So the next one we will come here, right? 2. At 2 what is the value? At index 2 what is the value? 3. So we will go to the C at index 3. What is my value over here? Maybe previously it was 5, right? We used 2 times 5. So then we will go at B at 4, not at 5, okay. We will again decrease it by 1, so that B 4 we will put this 3, so this 3 will go here. Now we will come here at index 1, the value is 5, then we will go with index 5, then we got value 8. You see that if we did not subtract 1 over here, then we would get, we do not have B with index 8, right? We would get a problem over here. So here we will put this value 5 at B 7, not 8. And the last one, then whenever I put it, then you will decrease by 1, 7, and the last one will get 0, right? This is our last position. Oh, I did a mistake over here, so I initialize, I did not put I greater or equal to 0. It should be here, right? I did not put the condition over there, sorry, my mistake. Okay, this one I equal to 0, so then the value is 2, so we will put this value where? We will go C at index 2, okay, and whatever value we retrieve 4, then we will decrease this 4 by 1, then we will go B 4 minus 1 at B3, so B3 0 1 2 3, so at B3 we will put these 2, so these 2 will be going over here. So ultimately you see that ultimately at the time the loop completes, then we will get our B array, so that is sorted array. Finally there is one more step that they did not write it here, that we need to copy this B value to A, this B array to A. Copying an array to another array is linear time, okay, that is for a single loop, for I equal to 0 to like this one, for I equal to 0 to I less than a dot length I plus plus a I equal to bi. Very simple. It seems a small algorithm, but it's difficult. Okay, in your test you may be given a data set and asked to write all the steps, to show the all of steps. So in now if you go to the book, you see that it does not say all of the steps. It does not say all of the steps. So what, let me explain it from the book. What does what did it do? Okay, so this is array, given array A. So it counted the it made the cumulative count array. So that what it says that how many zeros are here. These are called key values. So there are 2 zeros, right?
Yeah.
2. So how can I get this 2? Like we go through one by one, and if there is any value that matches with this, we update this. Initially all C was all 0, right? So here we use this algorithm, this one. Okay, this one, these lines. C of AI is equal to C of AI j plus 1. So then it got 2. What does this C tell us? It says there are 2 zeros. There is no 1. There are 2 2s. There are 3 3s. There is no 4. There is 1 5. Right? See that one. Now this is a cumulative updated C. Right? As I said that at this point I could say the output. I could say that there are 2 zeros. So 0 0. 2 zeros. This is the output. And there is no 1. So there is no 1. And there are 2 2s. So the next 2 is 2. 2 2. And there are 3 3s. So next 3. Okay. And there is 1 5. So this one only 1 5. So ultimately I could jump from here to here. From here, ultimately, we could jump. I'm sorry. Sorry, I missed it. Okay. Ultimately, I could jump from here to here, but in order to maintain place, we need to do all our internal things. The first one is that this is the cumulative C. Okay. It contains 2 plus 0. First one is same. Okay, then 2 plus 0 equal to 2. Okay, and then 2 plus 2 equal to 4. Then 4 plus 3 equal to 7. Then 7 plus 0 equal to 7. And then 7 plus 1 equal to 8. So now we got this one. Now we are going to our original given array. So now if whatever you like, if you write your algorithm like this way, so then you have to explain this way. So that we are going to the original array, the last value we got 3. Okay, and in C at position 3 we got 7. So they put at 7. They did not, since they started with index 1, they put at 7, they put 3. What is the 3 value? This 3 value they put at 7. And then they are going to this one, left one, they put 0. They are putting 0 where? They are going to a 0th index. It values 2. So at position 2, they put 0. So already this value was over there. This is C, then D. So this value was already over there. Okay. And what is doing over here? So once they put 1, they decreases the corresponding value. So at here, position was, what was that called? 3. At 3, the value as you say the 7, that is decreased by 1 3 once they put 1, and then over here whenever they put at 2, the positive value was 2, on a value was 0, this one is 0, so at index 0 the initial value was 1 2, so then as soon as they put this value, they decreases this 2 by 1. Okay, so ultimately these 0, these will tell us that there are 2, we know that there are 2 zeros, right? So it will go until it does not become 0 2 to 1 to 0, it will, the loop will find it. So does anyone has any question? Okay, so please, okay, try to understand this. Okay, and then if you understand this, then 2 other algorithms, those are easy. In my I have counting sort algorithm, the program written completely over here. So this is counting sort algorithm, this is counting sort, this method. Okay, it takes an array and k. We know that k value is our what is our k value? We can find the k value is the range, right? Okay, and this is my out array, this is dynamic array. We can get length over here from length, and then we declare the size over here, the output array. And then this is my count array or C array. You can put C, you can say C or count, whatever you like. Okay, is equal to, its size will be taken k plus 1. Okay, so I put k over here so that I will get, whenever I call this method, I will get k equal to max element, k equal to max element. So max element plus 1. Okay, then initializing the count array with all 0 and updating with the number of key elements occurrence is over here, and this is the cumulating addition, and these are the these 2 lines are the difficult lines that makes the output array. And finally this line, of course, is the copying the output array to input array. So in this program I have written this return type of this method will be an array. You could make it void. So if you make it void, then you don't need this return statement. Okay, and then codes are called in the main method. So main method, this is how it is called. So it will be an array and the max element. So this max element will serve the purpose of k. Okay, I'm giving you these lines of code. So if we run this, you see this program will work. But at the beginning I told that there are some limitations, right, of counting sort. What are the limitations? Number 1, it cannot work with negative numbers, and then it cannot work with decimal values. Okay, 2 limitations, and we will see in our next lecture that we can do alternative way. Okay, we have other algorithms we can do. Okay, like bucket sort or radix sort algorithm we can do. Okay, before that, there is, see that it is working, but there is another limitation of counting sort algorithm, is that you see that its efficiency depends on k value. We will go in the book later, that's shown that maybe next lecture, that is running time is k plus n. Okay, give me 2 more minutes please. So the counting sort algorithm is not exactly linear, but is running time is theta k plus n. What is the k value here? Discuss, remember that? K value is the range, right? Or the max, the largest element, right? So based on the k value, remember that based on the k value, we declared our count array, right? So in our program, so here in our programs, so we have very smooth data. What is the range over here? K value is 5, right?
Yeah.
If I have a very large k, for instance like this, let me start with this one, 5000. Okay, then what is the problem? Do you remember any problem?
Your C arrays will be really big.
Yeah, your C array will be very larger, right? Then your C array will have size k plus 1, right? In that case, our C array will be 0, 1, and what is the last index will be? Index will be k. Last index will be k, right? So that means k plus 1 element. It has size is k plus 1, right? So then within this k plus 1, k equal to maybe 5000 or 50,000, whatever it is. And within this 50,000 space, how many data we are saving here? Only 8 values, right? We are saving only 8 values. Maybe 2, we are putting only 8 values in the original array. In the original array has only 8 values. So that there will be many values same, right? So can I go back to? Okay, you see that for this array, for the cumulative array, if there is nothing, for instance, it will have a very large number, dot 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 with 50,000, 50,000, right? So for all of this number will be 0, 0, 0, 0, 0, 0 unnecessarily, right? So we see that this is running time is k plus n. So if n equal to, for instance, if k is larger than n, so which part is dominant? K is dominant, right? So it does not meet our goal that we will have our running time n, right? It will take very large array, it will take more time, right? So it's not linear in that case. So this algorithm does not work efficiently in case of some outliers. Outlier means that if there are few numbers out of range. You understand? Like one value is very large. For that, in order to maintain one value, we need to declare the C array with large size, and that will ultimately dominate our running time. So you got 3 limitations, right? Okay, we will keep these limitations in our mind so that in the next lecture, I'm sorry, I had my plan to discuss 2 other, but we have 1 more lecture. Hopefully we will complete this in our next lecture. But I am giving you this code, so please play with this, and what you will do, you will change this program so that you can sort it in descending order. And there is a way, if you can do it, if you want to do using some extra algorithm, we can work with negative numbers here. But since these numbers are used with index, so it is difficult. The better algorithm is to use positive. If there is a single negative number, we will go other algorithms. Okay, so I'm giving you this code. So please practice this, and as usual please practice this program and work it for descending order. Okay, thank you everybody, and you have a good evening.